So good evening, everyone. This is lecture number 5, and we are dealing with photoelectric effect. In the last class, we had seen the entire concept of photoelectric current and what all factor it depends on. We had seen how does the photoelectric current vary with potential difference. We had seen how it varies with the intensity, if you make intensity less or if you make intensity more. We had also seen the effect of frequency on photoelectric current. Yes or no? Now what we'll do today, we'll write all those points together at one place so that if you have to revise them, you can revise them quickly, and then we can move on to the next part of this chapter. The first thing that we did was known as W naught or phi, which was known as work function. And this work function is the minimum energy required. Yes or no? Do we remember this? Minimum energy required to extract something out of, to extract the electrons out of a metal. And we had seen that this work function, is equal to H into F naught, or you can call it as HC by lambda naught, and H into C becomes 12,400. 12,400 divided by omega naught becomes your work function. Here F naught and lambda naught are your threshold frequencies and threshold wavelengths. Yes or no? We have seen this? Yes or no? Do we
Yes, sir.
remember?
Yes, sir.
Okay, these were the first things that we saw. Then what was the next thing that we saw in yesterday's class? Anyone remembers it? Anyone remembers it? We had seen what was threshold frequency, and we had seen that if F, the frequency of radiation, is more than F naught, then only your photoelectric current flows. If it is less than F naught, nothing happens. If lambda naught, if your lambda is less than lambda naught threshold wavelength, then only your photoelectric current flows. Do we remember this? Yes or no?
Sir.
Okay. Then we had seen the saturation current, IS, the saturation current, it only depends on intensity, and it does not depend on frequency. Do we understand this? Do we remember this? Then we had seen stopping potential V naught. It is the maximum negative potential of anode that stops photoelectric current. Yes or no? We had seen this V naught. It only depends on the frequency of radiation, and it does not depend on the intensity of radiation. Do we recollect this? Everyone recollects this?
Yes, sir.
Okay. Then we had seen the kinetic energy, the maximum kinetic energy of a particle that can be emitted will be equal to E into V naught. This stopping potential is the potential at which it stops the most energetic electron that comes out. We had also seen that the kinetic energy of all the electrons which are coming out is not same, but it is different. Some can have zero kinetic energy, some can have maximum kinetic energy. When we talk about maximum kinetic energy, it is a fictitious case. Which particle will have maximum kinetic energy? For example, if this is an electron which is moving in an orbit, and this is a photon which strikes it. Now, which particle will have maximum kinetic energy? This is moving. So this particle strikes it. Dadang. When it strikes it, it must give 100% of this energy to this particle, which is not possible. Okay. If it gives 100% of energy to this particle and this particle just moves out, then it will have the maximum kinetic energy. It's a theoretical concept. It is not possible because when this photon attacks this, when this photon is falling on this, some part of energy will be lost in heat, light, or other things. But if it absorbs the entire energy and it just moves out of the metal, remember in the metal there are millions and millions of electrons revolving. So if it has to move out, it has to move out without any collision, because if any collision happens with any electron, it will still lose some energy. So maximum kinetic energy cannot theoretically happen. But yeah, in the question that you will have, you might have this question of finding out the maximum kinetic energy. Do you understand when do we have maximum kinetic energy? So there can be a question where they will tell photon is falling, 10% of energy is lost. So you have to take 90% of energy. After absorbing the energy, electrons comes out after two collision. In one collision, this energy is lost. So you have to find out what is the energy left with it. That would be the kinetic energy. Do you understand this? Yes or no?
Yes, sir.
So electrons which are coming out, which are ejected, can have zero kinetic energy, as well as the maximum possible value of kinetic energy. The maximum possible value of kinetic energy is equal to E into V naught. Do we understand this? Everyone understands this? Yes or no?
Yes, sir.
Yes, sir.
Okay. Then we had seen the effect, what effect intensity has on the photoelectric current. We had seen that if you increase intensity of radiation, the intensity of radiations is increased, photoelectric current increases, but this will also only happen when the energy of the radiation is more than work function. When the energy of when the frequency is more than threshold frequency, then only these things will happen. Otherwise, nothing will happen. For photoelectric effect to happen, the first and the foremost thing is, what is the first and the foremost thing? The first and the foremost thing is energy of the radiation should be greater than work function. Frequency of the radiation must be greater than f naught, and lambda of the wavelength must be less than lambda naught. If one condition is met, all the three conditions are met because they are related to each other. Do we understand this? If you increase the energy of radiations, or in that you increase the frequency of radiations, the stopping potential ka value increases. Do we understand this? Now this is the entire chapter in one glance. If you can remember these things, you are good to go. I'll give you 2 minutes to note them down.
Completed, sir.
Boys, are we done?
Yes, sir.
Completed, sir.
Okay. If you have done this, most of the things are done. You just have to see one more thing in this chapter that is remaining, and that is known as the Einstein's equation. Have you seen this Einstein's equation?
Yes, sir. E equals to MC square.
No, that is not the one that I am talking about. Einstein's photoelectric equation. Have you seen that equation? Did you know Einstein got a Nobel Prize? Sir Albert Einstein got a Nobel Prize. Do you know this? Yes or no? Do you know that Sir Albert Einstein got a Nobel Prize? How many of you don't know this? He got the Nobel Prize for this equation, the equation that we are going to see now, the Einstein's equation. And that is not E is equal to mc square. That is now this Einstein equation is based on simply law of conservation of energy. This Einstein equation is basically uh, based on law of conservation of energy, and basically what it means is, remember, he says that light consists of particle photons. So one electron, as I said, will be hit by one photon. If there are more photons, more electrons would be hit, and therefore more would be the photoelectric current. Now, if a photon with some energy hits, so let me call that energy as E. Energy of the photon, E. Now this energy of the photon will be given by h into f. Do we understand this?
Yes, sir.
E is the frequency, h is the Planck's constant. Now, where this energy can go when this photon hits, where will this energy go? Some part of energy will go to overcome the electron, to overcome the work function of the metal, yes or no? Then the rest of the energy may be lost in the form of heat or any such energy. The electron may collide. While coming out, the electron may collide with the neighboring particles. So some sort of energy may be lost. Whatever energy is remaining with the electron, it comes out with that kinetic energy. So this becomes the Einstein's equation for photoelectric effect. This becomes the Einstein's equation for photoelectric effect. Now, if I assume that there is no energy lost in the form of heat or any such events, whatever energy is coming, dung, 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 this electron is getting that energy and it is going pung, 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 pung. In that case, that electron will have maximum kinetic energy, and the equation becomes W or W naught plus KE max. This becomes your Einstein's equation. Do we understand this?
Yes, sir.
Now you can write this equation in various forms. I'll give you 2 minutes. Have you written this up till here? Okay, I'll give you 2 minutes to note it down.
Completed, sir.
Girls, are we done?
Yes, sir.
Okay. Now, what are the various ways in which you can write this? The more the number of ways that you can remember, the better you are going to be. HF, This work function can be written as H into F naught, yes or no? This kinetic energy can be written as half mv max square, yes or no? Sometimes they might ask you the velocity of the electron that is coming out. Very rare those questions are, but they can ask you. So you can write it like this. Everyone is getting my point, yes or no? You can write it in this way. HF is HF naught plus this maximum kinetic energy is equal to E into V naught. Equation number 3. Instead of writing it at HF, I can write it as HC by lambda. And I write this as HC by lambda naught plus E times V naught. You can also write it in any combination of these two. Energy can be written as H into F or H into C by lambda. Work function can be written as H into F naught or H into C by lambda naught. You can interchange them. Kinetic energy can be written as KE max. Remember, it is maximum energy because there is no energy lost. Or it can be written as half mv square, or it can be written as E into V naught. Do we understand this? Yes or no? No or yes? Do we
Yes,
understand?
sir.
Then from this, I can draw a graph between kinetic energy and the frequency. Kinetic energy. You can write this kinetic energy in terms of, see, I can write this equation in this fashion. I can write this equation as KE max will be equal to H into F minus omega naught. Yes or no? Now I can draw a graph. Everyone has noted this down? Now I can draw a graph between now I can draw a graph between maximum kinetic energy and frequency F. Do we understand this? Now for different metals, the graph would end up at different places. This position is known as work function of the first. This will be the work function of the second. This graph will meet y-axis at different points, but they would have the same angle of inclination because the slope of the graph is always equal to h. Do we understand this?
Yes, sir.
Tan theta of this graph is h. Tan theta of the graph where we had v stopping potential plotted was h by e. Do we understand this? Do we remember this? This is the graph. If you want, I will show it to you again. Have you noted down this graph?
Yes, sir.
Then this is the graph that I was talking about. Graph between V naught stopping potential and F. You can write the stopping potential V naught as H by E times of F minus work function divided by E. So as you can see here, the intercepts are work function of metal 1 divided by E, work function of second metal divided by E, and tan theta of this graph is H by E. I'll give you 2 minutes to note this down.
Completed, sir.
Girls, are we done?
Yes, sir.
It is girls or boys? Girls, are we done?
No, sir.
Do it quickly, sir. Now remember, whenever you get questions on this type, the questions may require a bit of calculations. Don't get scared with those calculations. You can, the questions that you will get most of the time, that will be theory based, and the calculations will not be that much. But if there is a calculation based question, it's a calculation based question, and nothing can be done for it. Shall we move ahead?
Yes, sir.
Let us start with the first question. Simple question. This is the first one. It obviously has come in one of the previous year JEEs. Can I have the answer for this one? You'll have 2 minutes to solve this. The work function of a substance is 4 electron volt. What is the longest wavelength of light that can produce photoelectron emission? Approximately.
Option C.
Option C. Anyone got the answer? How do you get this option C? Anyone? So, work function is given. You just have to put the formula. Work function W naught is E into V naught. The longest wavelength. Work function is not E into V naught. That was the maximum kinetic energy, that was E into V naught. Work function is H into F naught, or I can call it HC by lambda naught. Yes or no? So
Yes,
to
sir.
find lambda naught, I just divide HC by W naught. Now you don't have to multiply H into C. You must know that H into C can be approximately written as 12,400. And then the Armstrong, then the value of lambda you will get in Armstrong units. Yes or no? So divided by the work function is 4. What do you get the answer? You will get 3100 Armstrong unit. 3100 Armstrong unit is 310 nanometer, and that is the answer. Do we understand this?
Yes, sir.
These are the simple type of question. You should get some of these questions, and the other question would be simply based on graphs. Do we understand this? Here comes the next one. The more the questions you do, the better you are going to be. 2 minutes you have.
Option C, sir.
Option C. That is correct. How did we get it? It's very simple. You just have to use the correct formula in the correct sense. So, how do we do this? All are based on Einstein's photoelectric equation. So I write the Einstein's photoelectric equation. Energy of the falling photon should be equal to W naught work function plus KE max. Or instead of writing it as KE max, I can write it as E into V naught. Do we understand this? Yes or no? This energy of the falling photon is 6 electron volts. This will be equal to 2.1 electron volts plus E multiplied by V naught. Answer is in electron volts. So 3.9 electron volts is the answer. So the voltage is 3.9 volts. 3.9 volts multiplied by E is electron volts. We understand this? So the stopping potential is 3.9. It cannot be positive. It has to be negative, and that is why it is negative. We get this? Yes or no?
Yes, sir.
Sure.
Good. The more the number of questions, the better you are going to be. And I'm going to give all types of possible questions that are possible in this category. Here comes the next one. And I hope you can do this. When radiation of a wavelength lambda is incident on a metallic surface, the stopping potential is 4.8. If the same surface is illuminated with radiation of double the wavelength, then the stopping potential becomes 1.6. These questions are coming in JEE. What is the threshold wavelength? I'll give you 2 minutes. Just watch anyone with an answer. No one got the answer? Oops. Shall I do it?
One second, sir.
Okay. This question has come in one of the JEEs, IIT JEEs. I'll show you the original question also. It was before this exam. Okay, I think I need to do it now. It's taken too much of time. How are we supposed to do this? Anyone? And let me see if I have that original question also. It's here. Huh. When light of wavelength lambda is incident, so what do I do here? Question number 4. I write the first equation. Lambda is incident. Stopping potential is 4.8. So E into V naught, stopping potential is equal to H into C by lambda naught minus 1 by lambda minus 1 by lambda naught. You understand how I've written this equation? Yes or no?
Einstein equation.
Einstein equation just written in a different form. I've written it in terms of work function. I can take this actually E out from here and I can just divide it by E. 1 by lambda minus 1 by lambda naught. And here this V naught is actually 4.8. Yes or no?
Sir,
Yes.
4 lambda.
4 lambda is the answer. That is correct. Here it is 4.8. Now if I do it in the second case, it is 1.6. These are the small things that you have to remember, beta. This is lambda, I don't know, I call it lambda dash minus 1 by lambda naught. You just have to solve these two equations. You divide these equations. You should be able to solve them. Lambda dash is given as 2 times lambda. You should be able to find lambda naught from here because these two are cancelling out. And this is also cancelling out. In fact, this is 1 by 3. Yes or no? This is
Yes, sir.
very simple case. You should be able to do this. Having said that, this was the question that looks like everyone got this answer. Huh? You understood
Yes, sir.
this? Okay, then you can solve this question, which was the original question from which this question was derived. This is nothing different about it. They've just not given the what it is doubled or tripled. They've just given it in this form. So fatafat give me the answer for this one. Since you know how it is done. So I think you can give me the answer for this one quickly. Quickly. Yes, bacha. Do we have anything that looks like an answer? Feels like one? Eh? Look like you need time? I'll give you time, don't worry. Time is a luxury that we don't have, but still I will give you whatever time you need. Everyone is trying, that is good. Remember, they just change something here and the question starts to look different. It is not that different. They've just not given the values. That is the only difference in this question and the question that actually appeared in one of the JEEs. So don't worry, nothing has changed here. Just because I've told you that this question is from an IIT-JEE, Purana IITs, that doesn't mean that it is tough. That means that it is simple. Huh? No answer still. Shall I intervene? Fast, fast, fast. No one is saying anything. Oh no.
N plus 1 lambda.
I've got an answer n plus 1 lambda. Let me check with the answer that I have. And the answer is n square lambda, my dear friends. See, when the lambda was halved, it actually became 4 times. N square.
Sir,
Yes, beta.
n square lambda by 2n plus 1.
The answer that I have in the sheet, and I don't trust these sheets. The sheets are being made by me, and some of the typists and typists do make mistakes. Shall we do it again? I'm always up for doing it again. So let us do it again and see if the answer is somewhat different. Okay. So in first case, when light of wavelength lambda is incident, the stopping potential is found to be x. So x becomes hc by e 1 by lambda minus 1 by lambda naught. Second case, n lambda is used, stopping potential is x upon n plus 1. X upon n plus 1 is equal to hc by e into 1 by n lambda minus 1 by lambda naught. You just have to divide, get the answer, and stay happy. What is the answer that you're getting from here?
N square lambda.
See, so the typist and I were wrong. We were correct. Lambda naught is n square times lambda. Did we get this or not? Yes or no? Do we understand this?
Yes, sir.
Shall we move ahead in life? Life has to move on.
Yes,
Huh?
sir.
No, sir.
Oh, sir.
Got it? Or
Got
shall
it.
I wait? Chalo. Do it fatafat. If you don't do it fatafat, today is the last day that we are going to do this. I can't extend this class for tomorrow. So the faster that you do it, the more questions you can do. When radiation is incident on a photoelectron emitter, the stopping potential is found to be 9 volt. This is very simple. I'm not worried about the calculation. I'm only worried that they've asked you the maximum velocity. So you just give me the formula and we are done and we'll move ahead in life. Life has to move on. Do it fast. Fast, fast, fast. Oh, I probably have to extend this class in the next class. Okay. Because the category is still more. Yes. When the radiation is incident on a photoelectron emitter, the stopping potential is found to be 9 volt. If E by M, charge by mass ratio, For the electron is something something. What is the maximum velocity of ejected photons? Not ejected photons, ejected electrons. Yes, my dear. I'm not getting any answer, dear. Where is the answer, dear? Is there any way? An answer coming from anywhere, dear? Doesn't seem like, dear. No answers, anyone? It might require some calculation,
Doing, sir.
but I hope you should be able to give me an approximate answer. Approximation is what I am after. Chalo, shall I intervene? Huh? I think I need to intervene here, and I shall. So what you need to do, bacha, is not very mushkil, very difficult. The kinetic energy, the maximum kinetic energy, half mv max square, is nothing but equal to E into V naught. Yes or no? So my V max becomes 2 times E by M into V naught, its root. That's it. That is what we were looking at. You just have to calculate this, get the answer, and stay happy. Nah, what are we getting? This is the simplest calculation in the entire universe. If you can't do this calculation and you are taking so long to do this calculation, well, what would I say? What is the answer? Man, you can't calculate
D,
this
sir.
simple thing.
Option D.
Option D. That is also wrong. Option C.
Option C.
This is the simplest calculation in the entire universe. 2 into 9 is 18, and that is 1.8. You take 1, 8, and it's the 10 raised to the power 12. It will become, and its half is 6, and 1.8 into 10 raised to the power 6. I can bloody do it orally without using my copy and pen. And I am a 44-year-old person whose brain has gone dead. And you with all the utensils, copy, pencil, brain, eyes, ears, everything, can't do it. Shame on you. You have to do this orally. In my time, I used to look at this. Okay, this one, takak, answer. That's it. And then I got ready 1826 rank. And I was probably 150 times sharper than you guys. Then I got an 1826. Now you multiply it by 150, your rank is out of this universe, and you will only get to see the door of an IIT and just see it and move out. Yes, these are simple questions, beta. These are simple calculations. You should do them quickly. Please try and do them quickly. Remember, JEE these days is just about your calculating speeds. And what I see, your calculating speeds are very bad. And it does not take rocket science to improve your calculation speed. Just do calculation. Give your hand some work to do. Calculation is the work that you should do. Work on your calculation, not on your physics or solving questions. You solve this big question, but you can't do small calculations. And that is not a problem of your maths. That's a problem of your laziness, that we can't calculate. This one, light of two different frequency have photons of energy is this and this. Successively eliminate a metal of work function this. What is the ratio of maximum kinetic energy? Yes, the answer is. These are the questions that are coming these days. And the person who gets selected in IIT does this faster than anyone else. Ah. Do I see an answer anywhere on the way that I should wait for? Did you get that sheet that I sent you? That sheet will have more questions like this. Similar pattern, similar things. Just try them. Yes, anyone with an answer here?
1:4.
1:4. I will not tell you how to do this. Everyone knows how to do this. Yes or no? Just had to get the answer. Kinetic energy, KE, can be simply written as KE max, can be written as energy minus W naught. So if I have to find out the ratio, what I'm writing? KE1 by KE2, that will be equal to E1 minus omega naught, W naught, E2 minus W naught. You just put the values. E1 is 1 minus 0.5 divided by 2.5 minus 0.5, and you end up with your answer as 1/4. Everyone got this?
Yes, sir.
Chalo, sir. Next one, sir. One of the questions in one of the JEEs. The question keeps on repeating in different engineering exams. Yes. Now, photoelectric emission is observed from a metal surface of this. F1 is V1 is V1 is F1 is greater than F2. The maximum values of kinetic energy in the two cases are in the ratio of 1:K. Ulta question of the question that we had done. The ratio of kinetic energy is given. You have to find out the threshold frequency. Yes, and I await your answers. Remember, it is a simple question that has to be done simply. Just because it has come in an IIT, you should be more confident that since it has come in an IIT, it has to be a very simple question, and that is why it has come in an IIT. IIT, they give simple questions so that you can solve them simply. Tough question never come in an IIT. Tough question don't exist. So only simple questions come, and we should be able to solve simple questions. Those questions are simple. Yes, anyone with an answer to this one, my dear friends? It looks like I will get an answer today. Yes or no? No, yes. Is the answer coming from anywhere? Ting 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 ting. Answer come, answer come. I'm waiting for the answer. Is it coming from anywhere?
Doing, sir.
Coming. I have full faith that will come from somewhere.
Sir, option B.
Option B. Let me check. Option B looks good. Option B looks good. Let me check with the answer sheet. Yes, option B is the correct answer. K times F1 minus F2 divided by K minus 1. That looks good. Well done. Question number 6 or 7 or whatever it was. How we need to do this again? We just apply the same concept. In the previous question, we had also applied the same concept. So K1 was H into F minus F naught, F1 minus F naught, and K2 was H into F2 minus F naught. You divide it, K1 by K2 should be F1 minus F naught. These are the type of questions that are going to come, boys and girls. And this K1 by K2 is given, I think, as what? 1 by K. So you can do dung and get your answer and stay happy. You understand this? Since the time is over, and I'm still left with some of the type of questions. Some question on saturation current, they can come. So what I'll do is photoelectric emission cells, it's also come. Okay, then there is no point left, but I'll have to extend this class into the next one. So we will be winding up this photoelectric effect probably in the next class. Not possible for me to do it here because some questions are left. And if those questions come and you're not able to answer, that will not be good. So meanwhile, while you go home, you have anyone has got that sheet that I sent after so much of hard work? Anyone has got that sheet? No one?
Yes, sir. God, sir.
Has anyone tried that sheet?
Started, sir.
Okay, started, sir. So finish it by tomorrow, sir, because after tomorrow we'll move on to X-rays, sir. So in that sheet, X-rays also there. So that sheet is meant for photoelectric effect and X-rays and matter waves. 3 topics are there. So finish it. What is the day today? Thursday. Finish it by Sunday, because by Sunday we should wind up your X-rays as well as your photoelectric effect. And from Monday onwards, we'll move on to the next topic in modern physics. Since we have started modern physics, we'll complete modern physics first. So we'll complete modern physics, and then the only thing that is left is electro, and we'll start with electro and see how much electro we can do. Okay?
Sir,
Yes,
sir,
beta. Hmm.
what is the Sunday test portion, sir?
What is the Sunday test portion, sir? Everything that we have done so far. Up till I will not give X-rays. I will give photoelectric effect. I will not give X-rays. Okay? Apart from X-rays, everything else. It will also include thermodynamics, maybe.
Okay, sir. Thank you.
Bye.